Antarctica. The name conjures images of icy plains, towering glaciers, and penguins huddled against the relentless cold. It's a continent of extremes, a place of stark beauty and unforgiving conditions. But beneath this frozen facade lies a secret, a hidden world of fire and fury. Antarctica, you see, is home to volcanoes. Lots of them. This might come as a surprise. We tend to associate volcanoes with tropical islands or dramatic mountain ranges, not with a landmass buried under miles of ice. But Antarctica defies expectations. It challenges our preconceived notions about what a continent should be, about where volcanoes belong. These aren't just any volcanoes either. They're unique, shaped by the extreme environment they inhabit. Some erupt beneath the ice, creating vast hidden caverns and spewing molten rock into the frigid waters below. Others rise above the ice sheet, their peaks the only visible evidence of the heat simmering beneath the surface. The existence of these volcanoes is more than just a geological curiosity. It speaks to the powerful forces that have shaped our planet, forces that continue to operate today. By studying these fiery giants, we gain a deeper understanding of Earth's inner workings, its history, and its future. The idea of volcanoes in Antarctica might seem paradoxical. How can fire and ice coexist in such a harsh environment? The answer lies in the unique geological makeup of this icy continent. Antarctica, unlike any other continent, is a land of contradictions, a place where fire and ice dance a delicate and dangerous ballet. Beneath the vast ice sheet that blankets Antarctica lies a continent riven by tectonic forces. The Earth's crust is fractured into massive plates that constantly shift and grind against each other. Antarctica sits atop one such plate, and its interactions with neighboring plates have created a landscape riddled with volcanoes. These volcanoes are not merely a geological anomaly. They are a testament to the immense power of our planet's internal heat engine. The Earth's core, a sphere of molten iron and nickel, generates tremendous heat that rises through the mantle, the layer between the core and the crust. This heat, in turn, drives the movement of tectonic plates and fuels the volcanoes that dot the Earth's surface, including those in Antarctica. The presence of volcanoes in Antarctica, therefore, is not a contradiction, but a consequence of the very forces that shape our planet. It's a reminder that beneath the seemingly static surface of the Earth, a dynamic and ever-changing system is at work. Antarctica is often perceived as a vast, monolithic block of ice, a frozen wasteland devoid of any significant geological activity. However, this perception is far from reality. Antarctica is a continent brimming with geological wonders, a testament to the Earth's restless nature. It's a continent that has seen it all, from fiery volcanic eruptions to the slow, grinding advance of glaciers. Beneath its icy veneer, Antarctica harbors a complex and fascinating geological history. It was once part of a supercontinent called Gondwana, which began to break apart millions of years ago. As the continents drifted apart, volcanic activity played a crucial role in shaping the land masses we see today. The legacy of this ancient volcanic activity is etched into the very fabric of Antarctica. The transantarctic mountains, for instance, which divide the continent into East and West Antarctica, are a product of volcanic eruptions that occurred over millions of years. These mountains, some of which rise to heights of over 4,500 meters, are a testament to the immense power of these ancient eruptions. Even today, volcanic activity continues to shape the Antarctic landscape. Mount Erebus, located on Ross Island, is one of the most active volcanoes in the world, a fiery beacon in the icy wilderness. Its frequent eruptions provide scientists with a unique opportunity to study volcanic processes in an extreme environment. Volcanoes are, in essence, vents in the Earth's crust that allow molten rock, ash, and gases to escape from the planet's interior. This molten rock, known as magma when it's underground and lava when it erupts, is a potent reminder of the immense heat and pressure that exists deep within our planet. The types of volcanoes found in Antarctica are as diverse as the continent itself. There are shield volcanoes with their gently sloping sides formed by effusive eruptions of fluid lava. There are stratovolcanoes characterized by their steep conical shapes built up by layers of lava and ash from explosive eruptions. And there are even subglacial volcanoes hidden beneath the ice sheet, their presence only revealed by subtle depressions in the ice or by plumes of meltwater that rise to the surface. Each type of volcano tells a different story about the geological processes that have shaped Antarctica over millions of years. Shield volcanoes, for instance, suggest a history of relatively gentle eruptions, while stratovolcanoes point to a past punctuated by periods of intense volcanic activity. Subglacial volcanoes, meanwhile, offer a glimpse into the complex interactions between ice, water, and molten rock. The presence of such a diverse array of volcanoes in Antarctica is a testament to the continent's complex geological history, a history that continues to unfold today. It's a reminder that beneath the seemingly static surface of the icy continent, a dynamic and ever-changing system is at work. Section 5. Volcanoes. Windows to Earth's soul. Volcanoes are more than just geological marvels. They are windows into the Earth's inner workings, providing scientists with invaluable insights into the processes that have shaped our planet over billions of years. By studying volcanoes, we gain a deeper understanding of the Earth's internal structure, its composition, and the forces that drive its dynamic systems. The study of volcanoes, known as volcanology, is a multidisciplinary field that draws on geology, geophysics, geochemistry, and even atmospheric science. Volcanologists use a wide range of tools and techniques to study volcanoes, from seismometers that detect earthquakes associated with volcanic activity to gas sensors that measure the composition of volcanic plumes. One of the key reasons why scientists study volcanoes is to understand the hazards they pose. Volcanic eruptions can be incredibly destructive, releasing vast amounts of energy in the form of ash, lava flows, and pyroclastic flows, fast-moving currents of hot gas and volcanic debris. By studying past eruptions and monitoring active volcanoes, volcanologists can help to predict future eruptions and mitigate their impacts on human populations and infrastructure. Beyond their potential hazards, volcanoes also play a crucial role in shaping the Earth's climate and atmosphere. Volcanic eruptions release significant amounts of gases into the atmosphere, including water vapor, carbon dioxide, sulfur dioxide, and ash. These gases can have both short-term and long-term effects on climate, depending on their composition and the scale of the eruption. Section 6. Antarctic volcanoes, a unique breed. Volcanoes in Antarctica present unique challenges and opportunities. The extreme environment makes fieldwork difficult but rewarding. Studying these volcanoes offers insights into unique volcanic processes. Subglacial eruptions create a fascinating interplay of fire and ice. These eruptions can be more explosive due to trapped gases. Scientists use remote sensing to map and monitor these volcanoes. Section 7. A journey to the bottom of the world. Our exploration of Antarctica's fiery secrets has just begun. We've only just scratched the surface of this icy continent and the fiery depths it conceals. There's so much more to uncover, more to learn about this frozen land where fire and ice collide. In the next chapters, we will delve deeper into the history and significance of Antarctica's volcanoes. We'll retrace the steps of early explorers who braved treacherous seas and unforgiving conditions to chart this icy frontier. We'll explore the geological forces that have shaped this continent over millions of years, from the breakup of Gondwana to the ongoing dance of tectonic plates. We'll witness the awe-inspiring power of volcanic eruptions, from the fiery fountains of Mount Erebus to the silent, unseen eruptions beneath the ice. We'll examine the impact of these eruptions on the environment, both locally and globally, and explore how they have shaped the unique ecosystems that thrive in this extreme environment. Join us as we embark on this journey to the bottom of the world, where fire and ice converge to create a landscape of stark beauty and unparalleled scientific wonder. Antarctica, as we know it, is a relatively new creation. It wasn't always the ice-covered landmass we see today. Imagine a time when Antarctica was lush and warm, a land of forests and dinosaurs. Millions of years ago, it was part of Gondwana. As Gondwana broke apart, Antarctica drifted southward. Its climate cooled, forests gave way to ice, and dinosaurs vanished. A new era was dawning, the era of a frozen Antarctica. The legacy of Gondwana's fiery past is etched into Antarctica. It's a legacy written in stone, a testament to ancient volcanoes. The Transantarctic Mountains, dividing East and West Antarctica, are a volcanic archive. These mountains, some over 4,500 meters high, record Gondwana's fiery demise. Imagine fiery fountains of lava illuminating the polar night. It was a scene of both beauty and devastation. These eruptions left behind vast layers of volcanic rock. Even today, the Transantarctica Mountains remain active. Mount Erebus, on Ross Island, is one of the most active volcanoes. Its eruptions offer scientists a glimpse into the fiery heart of Antarctica. The Transantarctic Mountains are a place of stark contrasts, where fire and ice meet dramatically. Towering peaks, sculpted by eruptions, pierce the sky, cloaked in glaciers. It's a breathtaking landscape, shaped by geological forces over millions of years. The mountains are a testament to volcanic power. Jagged peaks contrast with smooth glaciers, a masterpiece of natural art. The breakup of Gondwana wasn't just a one-time event. It was a process that unfolded over millions of years, and its effects are still being felt today. In fact, Antarctica is still being pulled apart, albeit very slowly, by the ongoing movement of tectonic plates. This ongoing rifting, as it's called, is most evident in West Antarctica, where the Earth's crust is being stretched and thinned. This stretching has created a series of rifts, or valleys, that run for hundreds of kilometers across the continent. Imagine the Earth's crust being pulled apart like a giant rubber band, creating valleys and mountains in its wake. These rifts are more than just geological curiosities. They are zones of weakness in the Earth's crust, where magma from deep within the Earth can rise to the surface more easily. As a result, many of Antarctica's active volcanoes are located along these rifts, including Mount Erebus and the volcanoes of the West Antarctic Rift System. The ongoing rifting of West Antarctica is a reminder that the Earth is a dynamic and ever-changing planet. The same forces that ripped apart Gondwana millions of years ago are still at work today, shaping the continent and influencing its volcanic activity. Beneath Antarctica's ice lies a hidden network of subglacial volcanoes, a testament to the interplay of fire and ice. These volcanoes shape the ice sheet and influence its flow. Scientists use radar mapping and seismic monitoring to study them. Their heat can melt the ice, affecting sea levels. Subglacial volcanoes pose a unique challenge for scientists. Hidden beneath kilometers of ice, they are difficult to access and study. However, scientists have developed a range of ingenious techniques to unveil these subglacial secrets and shed light on the hidden world of fire and ice beneath Antarctica's frozen surface. One of the most valuable tools in the subglacial volcanologist's arsenal is radar mapping. Airborne radar systems can penetrate the ice sheet, sending out pulses of radio waves to bounce back from the ice and the bedrock below. By analyzing these reflected signals, scientists can create detailed maps of the subglacial landscape, revealing the presence of volcanoes, mountains, and valleys hidden beneath the ice. Another powerful tool is seismic monitoring. Seismometers, instruments that measure ground vibrations, can detect the subtle tremors associated with volcanic activity. By deploying networks of seismometers on the ice surface, scientists can pinpoint the location of subglacial eruptions and track the movement of magma beneath the ice sheet. In recent years, scientists have also begun to use autonomous underwater vehicles, or AUVs, to explore subglacial lakes, bodies of water trapped beneath the ice sheet. AUVs, equipped with cameras, sonar, and other sensors, can map the lake floor, collect water samples, and even search for signs of life in these extreme environments. Section 7. Volcanic Timekeepers. Reading the Rocks. Volcanoes are not just agents of destruction and creation, they are also timekeepers, their eruptions leaving behind a record of Earth's history, written in stone. By studying the layers of volcanic rock in Antarctica, scientists can piece together a timeline of past eruptions, understand how volcanic activity has changed over millions of years, and gain insights into the forces that have shaped this icy continent. Each volcanic eruption leaves behind a unique signature, a layer of ash and rock that can be dated using radiometric techniques. These techniques, which rely on the decay of radioactive isotopes, allow scientists to determine the age of volcanic rocks with remarkable precision. By dating the layers of volcanic rock in Antarctica, scientists have been able to reconstruct a history of volcanic activity spanning millions of years. This record reveals periods of intense volcanic activity, punctuated by quieter periods. It also shows how the location and style of volcanic activity have changed over time, reflecting the shifting tectonic plates and the evolving landscape of Antarctica. Volcanic rocks also contain clues about the composition of Earth's mantle, the layer of hot, solid rock that lies beneath the crust. By studying the chemical makeup of volcanic rocks, scientists can learn about the processes that occur deep within the Earth and how they have changed over time. Section 8. Decoding Earth's Autobiography. Antarctica's volcanoes are more than just geological wonders. They are chapters in Earth's autobiography. They're eruptions, recording the planet's history in fire and stone. By studying these volcanoes, we gain a deeper understanding of our planet's evolution, its dynamic systems, and the forces that have shaped it over billions of years. The study of Antarctic volcanoes is not just an academic pursuit. It has important implications for understanding the future of our planet. Volcanic eruptions can have a significant impact on global climate, injecting vast quantities of ash and gases into the atmosphere. By studying past eruptions and monitoring current activity, scientists can better predict the potential impacts of future eruptions and develop strategies to mitigate their effects. Furthermore, the study of subglacial volcanoes is crucial for understanding the dynamics of the Antarctic ice sheet and its potential contribution to sea level rise. As the planet warms, the melting of glaciers and ice sheets is a major concern, and understanding the role of subglacial volcanoes in this process is essential for making accurate predictions about future sea levels. Our journey into the fiery heart of Antarctica has only just begun. As we continue to explore this icy frontier, we can expect to uncover even more secrets about our planet's past, present, and future. Section 1. Whispers from the Deep Freeze. Imagine, if you will, Antarctica as a giant history book, its icy pages filled with stories of fiery upheavals and dramatic transformations. These stories, however, are written in a language we are only beginning to understand, the language of volcanoes. Each eruption, each spewing of lava and ash is a whisper from the deep freeze, a clue to the continent's fiery past. These whispers are faint, often buried beneath miles of ice and snow, obscured by the passage of time. But they are there, waiting to be deciphered by those willing to listen. And listen we must, for these whispers hold the key to understanding not just Antarctica's past, but also its potential future. Deciphering these whispers is no easy feat. It requires venturing into one of the most inhospitable environments on Earth, braving frigid temperatures, howling winds, and treacherous terrain. It requires innovative technology, from ice-penetrating radar to remote sensing satellites, to peer beneath the frozen surface and map the hidden world below. But the rewards are worth the effort. With each discovery, with each volcanic whisper, we decipher, we gain a deeper understanding of the forces that have shaped this icy continent, the forces that continue to shape it today. Section 2, Unlocking the Frozen Archives. Antarctica's icy grip holds more than just frozen landscapes and hidden volcanoes. It holds a treasure trove of geological data, a frozen archive of Earth's history. This archive, locked away in layers of ice and rock, offers tantalizing glimpses into the continent's fiery past, its volcanic eruptions, and their impact on the planet. Imagine each layer of ice and volcanic ash as a page in a giant history book. Each layer represents a specific moment in time, capturing a snapshot of the Earth's climate, atmosphere, and volcanic activity. By analyzing these layers, scientists can piece together a timeline of Antarctica's volcanic past, tracing its eruptions and their impact on the planet over millions of years. One of the most valuable tools for unlocking this frozen archive is ice core drilling. By drilling deep into the ice sheet, scientists can extract long cylinders of ice, some dating back hundreds of thousands of years. These ice cores contain trapped air bubbles, volcanic ash, and other particles that provide a detailed record of past climate and volcanic activity. Volcanic ash, in particular, is a valuable time marker, as each eruption leaves behind a unique chemical fingerprint. By analyzing the ash layers and ice cores, scientists can pinpoint the timing and magnitude of past eruptions, even those that occurred thousands of kilometers away. Section 3, Early Explorers, Glimpses of Fire and Ice. Long before scientists began drilling into the ice and mapping the hidden world below, early explorers had their first encounters with Antarctica's fiery nature. These encounters, often fleeting and fraught with danger, provided the first tantalizing clues that this icy continent harbored a hidden heat. Imagine, if you will, the awe and trepidation of these early explorers, sailing through treacherous seas, braving howling winds and freezing temperatures, only to be greeted by the sight of a volcano spewing smoke and ash into the polar sky. It was a sight that challenged their preconceived notions of this icy continent, a stark reminder of the power of nature. One such explorer was James Clark Ross, who in 1841 led an expedition to Antarctica that would forever change our understanding of this icy continent. Ross and his crew were the first to lay eyes on Mount Erebus, an active volcano rising majestically from Ross Island, its slopes cloaked in ice and snow, its summit wreathed in smoke. This discovery sent shockwaves through the scientific community, challenging the prevailing view of Antarctica as a geologically inert landmass. It was a pivotal moment, sparking curiosity and igniting a desire to explore the fiery secrets hidden beneath the ice. Section 4, A Legacy in Ash, Mapping the Past. Each volcanic eruption leaves behind a silent testament to its fury, a blanket of ash, sometimes spreading thousands of kilometers from its source. This ash, a mixture of pulverized rock, glass, and minerals, may seem insignificant at first glance, but it holds a wealth of information for those who know how to read it. Imagine, if you will, volcanic ash as a time traveler, carrying with it a snapshot of the Earth's atmosphere. at the moment of its eruption. By analyzing the chemical composition of this ash, scientists can glean insights into the nature of the eruption, the composition of the magma, and even the climate conditions at the time. In Antarctica, where wind-blown ash can travel vast distances before settling on the ice sheet, this ash becomes a valuable tool for mapping past eruptions. By analyzing the ash layers and ice cores, scientists can pinpoint the source of the eruption, track its dispersal patterns, and estimate its magnitude. This ash also provides valuable clues about the frequency and intensity of past volcanic activity, helping scientists understand how eruptions have shaped the continent's climate and environment over millions of years. By piecing together this volcanic jigsaw puzzle, we gain a deeper understanding of the forces that have shaped Antarctica and continue to shape our planet. Section 5. Erebus, the restless giant. No exploration of Antarctica's fiery underbelly would be complete without paying homage to Mount Erebus, the continent's most active volcano and a symbol of its fiery heart. Rising from Ross Island like a slumbering giant, Erebus is a constant reminder that even in the coldest, most desolate corners of our planet, fire still burns. Imagine standing on the slopes of this icy behemoth, the ground trembling beneath your feet, the air thick with the smell of sulfur, as you witness firsthand the raw power of nature. Erebus is a stratovolcano, its conical shape built up over millennia by layers of lava and ash, a testament to its long and violent history. What makes Erebus truly unique is its persistent lava lake, a churning cauldron of molten rock that has been active for decades. This rare feature, one of only a handful on Earth, provides scientists with an unparalleled opportunity to study the inner workings of an active volcano, to peer into the heart of the Earth and unlock its secrets. Erebus is a restless giant, its frequent eruptions sending plumes of ash and gas high into the atmosphere, a constant reminder that this icy continent is far from dormant. By studying Erebus, scientists hope to gain a better understanding of volcanic processes, not just in Antarctica, but around the world. Section 6. A symphony of fire and ice. Subglacial eruptions. Beneath Antarctica's icy carapace, hidden from view, a symphony of fire and ice plays out on a grand scale. Subglacial eruptions, a dramatic clash of elements, create a world of hidden wonders, carving out vast caverns, melting massive quantities of ice, and reshaping the landscape beneath the frozen surface. Imagine the scene, a plume of molten rock, rising from deep within the earth, punches through the earth's crust, encountering not air and sky, but a solid wall of ice. The heat from this magma melts the surrounding ice, creating a growing cavern filled with meltwater. This meltwater, in turn, interacts with the magma, creating spectacular explosions of steam and ash. These subglacial eruptions are often silent giants, their fury muffled by the overlying ice sheet. But their effects are far-reaching. The massive quantities of meltwater produced can lubricate the movement of glaciers, accelerating their flow toward the sea. The heat from these eruptions can thin the ice sheet from below, contributing to its instability in a warming world. Subglacial eruptions are a potent reminder of the interconnectedness of Earth's systems, how forces deep within the planet can have profound effects on the surface. even in the most remote and inaccessible corners of our world. Section 7. Deception Island. A volcanic cauldron. Deception Island, a horseshoe-shaped island in the South Shetland Islands, is a volcanic caldera, a testament to the explosive power of nature. This submerged volcano, its caldera flooded by the sea, is a place of stark beauty and simmering danger. Imagine sailing into this flooded caldera, the sheer cliffs of volcanic rock rising up on either side, the water steaming from geothermal activity. This otherworldly landscape, both beautiful and menacing, hints at the island's violent past. Deception Island last erupted in the 1970s, reminding us that its volcanic heart still beats. Today, Deception Island is a popular tourist destination. Its geothermal hot springs, offering a unique bathing experience. The ghost volcanoes, silent but not forgotten. Not all of Antarctica's volcanoes are active, spewing lava and ash into the sky. Some lie dormant, hidden beneath the ice, their fiery past a distant memory. These ghost volcanoes, as they are sometimes called, may be silent, but they are far from forgotten. They hold valuable clues to the continent's geological history, their eroded cones and solidified lava flows, whispering tales of a fiery past. Imagine flying over the vast expanse of the Antarctic ice sheet, the monotonous white, broken only by the occasional mountain peak. These ghost volcanoes, often buried beneath kilometers of ice, are difficult to detect and study. Scientists are using sophisticated techniques, such as ice-penetrating radar and gravity measurements, to map their locations and unravel their secrets. Underwater eruptions, the hidden spectacles. While eruptions on land capture our imagination, a hidden world of volcanic activity thrives beneath the waves surrounding Antarctica. Underwater eruptions, hidden from our view, create a symphony of fire and ice, shaping the seafloor and influencing the delicate balance of life in the Southern Ocean. Imagine a column of magma rising from a vent in the seafloor, encountering the frigid waters of the Southern Ocean. As the molten rock interacts with the seawater, it cools rapidly, forming pillow lavas, rounded mounds of solidified lava that resemble pillows scattered across the seafloor. These underwater eruptions, often undetected by humans, are a vital part of the Earth's geological cycle. Scientists are using remotely operated vehicles, or ROVs, and other advanced technologies to explore these underwater volcanoes and study their eruptions. Volcanic time capsules, preserving the past. Volcanic eruptions, while often destructive, can also act as powerful preservers of the past. The ash and lava flows from these eruptions can entomb entire landscapes, creating time capsules that offer unique glimpses into ancient ecosystems. Imagine a forest thriving in a warmer, greener Antarctica, suddenly engulfed by a pyroclastic flow, a superheated avalanche of ash and gas. The trees, instantly killed and buried, are preserved in astonishing detail. Their trunks transformed into petrified wood, their leaves fossilized in layers of ash. These volcanic time capsules offer invaluable insights into the history of life on Earth, providing a record of past climates, ecosystems, and the evolution of species. As we delve deeper into the fiery secrets of Antarctica, we are reminded that this icy continent is far from a static, frozen wasteland. It is a dynamic, ever-changing landscape, shaped by forces deep within the Earth. Its volcanoes, both active and dormant, are a constant reminder that our planet is alive, its heart beating with a fiery pulse. By studying these volcanoes, we are not just satisfying our curiosity about this remote and extreme environment. We are gaining a deeper understanding of the Earth's systems, the interconnectedness of its processes, and the forces that have shaped it over billions of years. Each volcanic eruption, each whisper from the deep freeze is a piece of the puzzle, helping us to piece together the story of our planet's evolution. The exploration of Antarctica's fiery secrets has just begun. Antarctica's volcanoes, hidden beneath miles of ice, might seem like distant, slumbering giants with little impact on the world above, but their presence is a constant reminder of the delicate balancing act taking place on this icy continent. It's a delicate dance between fire and ice, a dance that has shaped Antarctica for millions of years and continues to influence its fate today. Imagine a seething cauldron of molten rock, trapped beneath a thick, insulating blanket of ice. The heat from this magma, constantly radiating upwards, melts the base of the ice sheet, creating meltwater that lubricates its flow towards the sea. It's a delicate equilibrium, a slow-motion dance between forces that can both create and destroy. This delicate balance is being tested as our planet warms. As temperatures rise, glaciers and ice sheets around the world are melting at an alarming rate, contributing to rising sea levels. Antarctica, with its vast reserves of ice, is a key player in this global drama. The heat from these volcanoes can accelerate ice melt, potentially contributing to the destabilization of the ice sheet and accelerating sea level rise. While most of Antarctica's volcanic eruptions occur unseen, hidden beneath the ice, some eruptions break through the frozen surface, announcing their presence with a dramatic display of fire and fury. These events, though rare, can have a profound impact on the surrounding environment, transforming the icy landscape and sending shockwaves across the continent. Imagine the moment a subglacial eruption reaches the surface. A plume of ash and steam explodes into the sky, a stark contrast against the pristine white. Molten lava flowing across the ice creates vast meltwater lakes that carve channels through the glaciers, reshaping the landscape in a matter of hours. These eruptions can have immediate and devastating consequences for local wildlife. Penguins, seals, and other creatures that rely on the ice for breeding and foraging can be displaced or even killed by the sudden changes in their environment. The ash fallout from these eruptions can contaminate water sources and disrupt the delicate balance of the ecosystem. Section 3. Cascading consequences. Ripples across the continent. The impact of a volcanic eruption in Antarctica extends far beyond the immediate blast zone. The ash and gases released into the atmosphere can travel thousands of kilometers, affecting weather patterns, air quality, and even the global climate. These cascading consequences highlight the interconnectedness of Earth's systems. How events in one part of the world can have ripple effects felt far away. Imagine a massive plume of volcanic ash rising high into the atmosphere, carried by prevailing winds across the continent. This ash, a fine-grained mixture of rock and glass particles, can block sunlight, causing regional cooling and disrupting plant growth. The ash can also contaminate water sources, posing a threat to wildlife and disrupting the delicate balance of the ecosystem. The gases released during an eruption, such as sulfur dioxide, can have even more widespread effects. In the atmosphere, sulfur dioxide can react with water vapor to form sulfuric acid aerosols, which can reflect sunlight back into space, causing a temporary cooling effect on the planet. These aerosols can also contribute to the depletion of the ozone layer, which protects life on Earth from harmful ultraviolet radiation. Section 4. Global Echoes from Pole to Pole. While Antarctica might seem like a distant and isolated continent, its volcanoes have the potential to impact the entire planet. The massive ice sheet, covering an area larger than the United States and Mexico combined, plays a crucial role in regulating global climate and sea levels. Any significant change to this ice sheet, even one triggered by a distant volcano, can have far-reaching consequences. Imagine an eruption so powerful, so explosive, that it injects vast quantities of ash and gases high into the stratosphere. These particles can circle the globe for years, reflecting sunlight back into space and causing a temporary cooling effect on the planet. This phenomenon, known as volcanic winter, has been linked to past periods of global cooling and climate change. Volcanic eruptions can also influence ocean currents and marine ecosystems. The interconnectedness of Earth's systems means that even seemingly isolated events in Antarctica can have global echoes, reminding us that we are all connected on this one planet. Section 5. A delicate ecosystem, life on the volcanic fringe. Life in Antarctica is tough, a constant battle against the cold, the wind, and the lack of sunlight. Yet even in this harsh environment, life finds a way. And in the shadow of Antarctica's volcanoes, a unique ecosystem thrives, fueled by the heat and chemicals released from these fiery vents. Imagine a landscape of ice and snow, punctuated by steaming fumaroles, vents that release volcanic gases and heat. Around these fumaroles, a surprisingly diverse community of microorganisms thrives, forming the base of a food chain that supports a surprising array of life. These extremophiles, as they are called, are specially adapted to survive in these extreme conditions. Some bacteria can convert volcanic gases into energy, while others can withstand high temperatures and acidic conditions. The volcanic areas of Antarctica offer a unique glimpse into the potential for life in extreme environments, both on Earth and beyond. Section 6. Penguins and pyroclastic flows. An unlikely pairing. While penguins and volcanoes might seem like an unlikely pairing, these two iconic Antarctic inhabitants share a complex and sometimes precarious relationship. Volcanic eruptions can pose a direct threat to penguin colonies, but they can also create new habitats and influence the availability of food sources. Imagine a colony of penguins nesting on a volcanic island, going about their daily routines of breeding and raising their young. Suddenly, the ground beneath them trembles, a sign that the volcano is awakening. A pyroclastic flow, a superheated avalanche of ash and gas, races down the slopes, engulfing everything in its path. Such events can decimate penguin colonies, destroying nests, killing chicks, and displacing adult birds. However, over time, volcanic eruptions can also create new habitats for penguins. The upwelling of nutrients caused by volcanic activity can boost phytoplankton growth, which in turn supports the krill and fish that penguins rely on for food. Section 7. Monitoring the behemoths. Predicting the unpredictable. Predicting volcanic eruptions, even in the most accessible parts of the world, is a challenging task. In Antarctica, where most volcanoes are buried beneath miles of ice, the challenge is even greater. Yet, scientists are developing innovative techniques to monitor these icy behemoths, hoping to glean clues about their behavior and provide early warning of potential eruptions. Imagine a network of sensors deployed across the vast expanse of the Antarctic ice sheet, listening for the telltale signs of volcanic unrest. These sensors can pick up the seismic waves generated by magma moving deep underground. Satellites orbiting high above the Earth also play a crucial role in monitoring Antarctica's volcanoes. By combining data from these various sources, scientists are building a more complete picture of volcanic activity in Antarctica. Section 8. Early warning systems. Protecting the frozen frontier. As human activity in Antarctica increases, so too does the importance of developing effective early warning systems for volcanic eruptions. These systems, designed to provide timely and accurate information about potential hazards, are crucial for protecting scientists, tourists, and the fragile environment from the impacts of volcanic unrest. Imagine a system that integrates data from multiple sources, such as seismometers, satellites, and ground-based observations, to provide real-time information about volcanic activity. This information, relayed to research stations, tour operators, and emergency responders, would allow for timely evacuations, flight diversions, and other safety measures. Such early warning systems are essential for minimizing the risks associated with volcanic eruptions in Antarctica. Developing these systems requires international collaboration, as well as ongoing investment in research and technology. Section 9. Harnessing the heat geothermal potential. While volcanoes are often associated with destruction, they can also be a source of clean and renewable energy. Geothermal energy, the heat generated from within the Earth, has the potential to provide a sustainable source of power for research stations and other facilities in Antarctica. Imagine tapping into the heat from a dormant volcano, using it to generate electricity or heat buildings. This clean and reliable energy source would reduce reliance on fossil fuels, minimizing the environmental footprint of human activity in Antarctica. Several countries with research bases in Antarctica are already exploring the potential of geothermal energy. Iceland, a country with extensive experience in harnessing geothermal energy, has conducted feasibility studies for geothermal power plants in Antarctica. While technical and logistical challenges remain, the potential benefits of geothermal energy in Antarctica are significant. This clean and sustainable energy source could help to power research stations, reduce reliance on fossil fuels, and minimize the environmental impact of human activities in this pristine environment. Section 10. Lessons from the Ice, a Global Perspective. The study of Antarctica's volcanoes offers more than just insights into this icy continent. It provides valuable lessons for understanding volcanic hazards and climate change on a global scale. The extreme conditions of Antarctica, while challenging, also provide a unique natural laboratory for scientific research. Imagine Antarctica as a giant petri dish, where scientists can study the interplay of volcanoes, ice, and climate, in isolation from other factors that complicate research in more temperate regions. The lessons learned from this research can be applied to other parts of the world, helping us to better understand and mitigate the risks posed by volcanic eruptions and climate change. For example, the study of subglacial eruptions in Antarctica can provide insights into the behavior of volcanoes hidden beneath glaciers in other parts of the world, such as Iceland or Alaska. The knowledge gained from monitoring volcanic activity in Antarctica can be used to improve early warning systems and disaster preparedness plans in other volcanically active regions. Antarctica's volcanoes, therefore, are not just a regional phenomenon. They are a global asset, providing valuable data and insights that can help us to protect our planet and its inhabitants. Section 11. The future is fiery. Antarctica's unwritten chapters. Antarctica's volcanoes, hidden beneath miles of ice, hold clues to our planet's past, present, and future. New technologies are opening up new frontiers of exploration. The interplay of fire and ice in Antarctica is critical as our planet warms. The journey of discovery has just begun. The fiery heart of a frozen world, a legacy of discovery. Our journey into Antarctica's fiery secrets takes us from frozen plains to subglacial lakes, from smoking volcanoes to labs deciphering Earth's whispers, witnessing nature's power, life in extremes, and cutting-edge technology. The human spirit of discovery drives us, pushing knowledge boundaries, understanding Earth's forces. From early explorers to modern scientists, using satellites and robots, the quest to understand Antarctica continues. Gondwana's legacy lives in transantarctic peaks and Mount Erebus's fiery breath. Beneath the ice, subglacial volcanoes, unique life forms thrive. Antarctica's events ripple globally, influencing climate systems, ocean currents, and atmosphere. Antarctica's volcanoes, once mysterious, now key climate players. Guardians of a global treasure, the enduring importance of Antarctic research. Antarctic research helps us understand global climate, sea levels, and life in extreme environments. The continent's unique ecosystem and volcanic activity offer insights into climate change and potential life on other planets. International collaboration in Antarctica exemplifies the power of global scientific cooperation. Scientists from diverse backgrounds work together to unlock the mysteries of this icy continent. From pole to planet, Antarctica's lessons for a changing world. The lessons from Antarctica extend far beyond its icy shores. Climate change, melting ice, and volcanic activity here affect us all. Studying these challenges provides insights for the world. Research on subglacial volcanoes aids global understanding. This knowledge helps develop early warning systems. Ice sheet studies inform climate models and sea level predictions. Research on extremophiles expands our understanding of life's limits. Antarctica is a microcosm of our planet's interconnected systems. Lessons from Antarctica guide us towards a sustainable future. A call to action, preserving the frozen frontier for future generations. Antarctica, with its unique landscapes and critical role in regulating the global climate, is a global treasure. Climate change and human activity threaten this delicate ecosystem. Protecting Antarctica requires international cooperation and sustainable practices. The future of Antarctica is in our hands. Let us ensure it is a story with a happy ending.